Okay, so now we have set up the model. Next step is to use solver to solve the problem, and solver is under data, and there is solver. Now solver is automatically installed by default, but it is not switched on by default. So the default is switched off. So you may not see solver under data. If you don't see it, then what you have to do is go to File, Options, okay, and then click Add-ins, and Excel add-ins. All right, so here is solver add-in. Make sure that that is checked and click OK. If it is checked, then you will see it. Click that. Okay. So now this is the screen, solver screen, and basically there are three major things that you have to do, and then there are a couple of minor things that you have to make sure that they are all properly set. Okay. The first thing is set objective. Okay. That is our objective function. Objective function for our problem is net profit. So click that. So you're identifying where the objective function is. Okay. Then you have three options here, and we will use only these two. You should never use this option. Okay. For linear programming, only these two. Okay. So either max or min. You have to make sure that you select the correct criterion for the objective function. So here there is net profit, so we're going to maximize. All right, so that's the objective function. The second thing is what Excel calls by changing variable cells. This is another name for decision variables. Our decision variables are in this range. So that's what we have to do here. We have to identify the decision range like that. Okay, so you don't have to type one by one, just indicate the entire range. Okay, so that's the second thing. And the third thing is to identify the constraints. So we have done the objective function, we have identified the decision variables, then the constraints. Now Excel solver allows you to enter groups of constraints all at once. You don't have to do this one by one. Once again, if you do one by one, even if you have lots of constraints, then it's going to take a lot of time. So here we can, since the sales limit constraint, they are all set up in one contiguous range. Okay, we can enter these constraints all in one go. So we identify that range. Okay, and here we have several options to choose from. Can be less than or equal to, greater than or equal to, and then there are three others. We will look at these later on. So we choose less than or equal to, on the right hand side is that. Right hand side is that. Okay, there are a couple of things that we need to understand. Okay, so now remember, we entered less than or equal to here, and that is only for the purpose of labeling what the constraints the nature of the constraints are. Okay, this is where you have to identify, and if this is the place where solver will look at for what type of constraint it is. So you must label properly, and labeling properly is for the purpose of making the model more reader understandable. And here is where the actual less than or equal to is applied. And of course, when you enter a group of constraints all together, the range that you specify on the left side must be the same size as the right side. So it should match. Each cell should be paired with another cell. Okay. Unless if it is just one number, then it can be just a number. But if it is range like this, then The cell reference is your left hand side of the constraint. Constraint value is the right hand side of the constraint. They both must have exactly the same number of cells in the range. Okay, so now you can click add. If you click add, it'll add this constraint and it'll keep you in the add constraint screen, so you can add more constraints. But if you're all done, then you can click OK, so which means it'll add the constraint and it'll take you back to the solver screen. Since we have the hours constraint yet to add, I'm going to click add. So now it added that constraint and we are still in add constraint screen. So now we'll go, and that's our labor hours needed. Again, I'm adding two constraints as a group, and it is less than or equal to, and it's that. That's the available. Okay, so now we are done. So I'm going to click OK. So that takes us back to the screen. Okay, so these are the three major parameters that we have to specify for solver, and then there are some couple of 2 or 3 different important items that you have to make sure. Okay, so here, make unconstrained variables non-negative. So this refers to the changing cells or the decision variables. Remember, non-negativity requirement for linear programming, and that's what this is. If you check this, you need to make sure that this is checked for all non-linear programming models. So this will automatically insert except 1 greater than or equal to 0, except 2 greater than or equal to 0. You don't have to enter them as a separate constraint. You should not. Okay, because this is available, you should not enter non-negativity constraints here. So you just check this. Okay. Now solver can be used not only for linear programming, it can be used for other types of mathematical programming models as well. But we are using, this model is a linear programming model. Okay, and the linear programming model uses what is called the simplex method. So this selecting a solving method, okay, that select a solving method, you must make sure that simplex LP is selected. If simplex LP is not selected, then that would be wrong. You may or may not get the correct answer. So that should be checked. This should be simplex LP. And then you can also go into options. Okay. Usually this will not be necessary. Options is necessary only when a couple of things happen. Okay. So when the numbers that we use for input, if they are vastly different, so if some constraints have parameters in the tens of thousands and some other constraints have the technical coefficients in small fractions, so you have scaling problem. So when you have scaling problem, linear programming will have difficulty solving. So it's a good idea to use automatic scaling. Okay, and if you have integer requirement, okay, we will talk about integer requirement later on. Right now we are not going to talk about that, but I'm just giving you a heads up. Now, if you have integer constraints, or if some variables are integer, then this integer optimality percentage will be important to set. It is by default 1%. So that means if solver finds a objective function value that is 1% for 1% or less than or equal to 1% away from the best possible value, then it will stop. Okay, so if you have 1%, then you may not, the answer that you get may not be the best. It could be just 1% away. So if you want the best value, absolutely, then you should put a 0 here. Why would you want to stop a little bit away from the optimality? So sometimes that last 1%, the finding that last 1% may require enormous amount of time, processing time. So the solver may go on and on and on for not just minutes but hours and hours. So if that, this is especially true if the model is a really large one. So in such a situation, in the interest of finding the solution fast, and that 1% may not be very significant, then you can put a value 1%. You can until I think Excel 2013, this default optimality used to be 5%. Now they changed to 1%. So if it's a really large problem, and if 5% is something that you can live with, then you can enter 5 here if you like. But of course, that's only if you have integer variables, but we don't have integer decision variables, so we'll just leave these as is. Okay, so now we have set up everything. Click solve. Now at this point, solver will tell you whether solver has found a solution or not. If you have any error in the model, then it will tell you solver did not find a solution. Okay, so now we do have a solution. All constraints and optimality conditions are satisfied. So you have that solution right there. Okay, and you can also generate reports as solver reports. So there are the two reports that are useful to us are the answer report and sensitivity. Actually, sensitivity is usually enough. You don't need the answer report because the answer is right here. The answer is in the model. Okay, but let's look at the answer report as well, just out of curiosity, and we will discuss sensitivity analysis in much more detail. Okay, so here is the answer report, here is the sensitivity report, and here is the solver answer.